Welcome to AI Podcast. Today we're digging into a new EMNLP paper called ReAgent by Xinjie, Zhao, Fan Gao, and colleagues from the University of Tokyo and NUS. Ready to talk reversible reasoning?
Let's do it. Give me the one-liner first. What is ReAgent in plain English?
ReAgent is a multi-agent question-answering system that builds a formal undo button into the reasoning process. When the agents spot contradictions, they can backtrack, fix the faulty step, and then continue.
So it's like using a GPS that not only reroutes you, it actually says, wait, we took a wrong turn 2 blocks ago, let's roll back to that corner and try again.
Exactly. Most systems go forward only. Once they make an early mistake, that error tends to snowball. ReAgent says, if later evidence disagrees with earlier assumptions, don't just debate it. Rewind to a consistent state and re-reason.
How do they pull that off? What's inside this thing?
They organize the system into specialized agents. There's a question decomposer that breaks a tough question into sub-questions. A retriever hunts for evidence. A verifier checks if new evidence fits what's already known. An answer assembler stitches partial answers together. Above them is a supervisor that coordinates big rollbacks and a controller that can challenge suspicious claims.
Nice division of labor, but what's reversible about it?
Two kinds of backtracking. Local backtracking is when a single agent, usually the verifier, finds an inconsistency in its own thread, say, two population numbers for the same city don't match, so it rewinds just that thread and rechecks. Global backtracking is when contradictions span multiple agents, like the retriever says one city is the capital, while another thread says something else. The supervisor rolls everyone back to the last globally consistent point.
So local is like undoing the last sentence you wrote. Global is like reverting the whole document to a saved version before things went off the rails.
That's a great way to put it.
The title also says knowledge enhanced. Does that mean they use search or a graph or both?
Both are supported. The retriever is designed to pull from text and, when available, knowledge graphs. In the experiments, they work with text corpora tied to the benchmarks, but the prompts and pipeline allow graph evidence too.
Got it. Let's talk about the problem they're trying to beat. Why is multi-hop QA so brittle?
Because you have to chain facts that live in different places. If your first hop grabs the wrong passage, every later hop is built on shaky ground. Traditional chain of thought or retrieval augmented methods rarely have a principled way to retract a bad intermediate step once it's accepted.
Okay, so what did they test and against whom?
3 multi-hop benchmarks, Hotpot QA, 2Wiki multi-hop QA, and MuseIQ. They evaluate on 1,000 validation examples per dataset. They compare against standard large models, dedicated reasoning models like O1 and O3, and other agent frameworks such as chain of agents. For a fair agent-to-agent comparison, they keep the same backbone, GPT-4 across the agent baselines.
And results?
ReAgent reports the best average scores across the 3 datasets with GPT-4 as the backbone. The headline is that the reversible design gives an improvement of roughly 6% over forward-only methods. It's especially strong on Hotpot QA, competitive on 2Wiki, and a bit behind the very long context specialists on MuseIQ.
That makes sense. MuseIQ tends to reward models that can juggle longer passages. Did they show why the backtracking matters beyond the averages?
They did ablations. If you turn off backtracking, accuracy drops. If you keep just local or just global backtracking, it helps, but having both is best. They also explored how far to backtrack. Deeper rollbacks help up to a point, then you get diminishing returns.
What about how many sub-questions to create? I've seen decomposers go wild and split everything into tiny pieces.
They check that too. Breaking a question into a few parts is valuable, but there's a sweet spot, about 3 sub-questions. Past that, you pay more in extra steps without getting much extra accuracy.
Can we make that concrete with an example?
Sure. They walk through a question about the state that hosted the 1984 Summer Olympics and whether its capital is smaller than its largest city. The retriever pulls facts about California, Sacramento, and Los Angeles. A bad data point slips in, an inflated population number for Sacramento. The verifier flags the conflict and locally rolls back, discarding the wrong number. Later, another thread drags in a claim that Los Angeles is the capital, which contradicts Sacramento. That's a cross-thread conflict, so the supervisor triggers a global rollback to the last consistent state, and the controller challenges the dubious Los Angeles is capital claim. The system re-verifies, resolves the contradiction, and the final answer returns to California.
That's a clean story. You can hear the undo click twice, once locally, once globally.
Exactly. It shows how reversible reasoning contains bad evidence before it poisons the whole chain.
Let's zoom out. Did they talk about costs and practicality?
A bit. ReAgent uses more steps than a single-pass model, so it's not the cheapest configuration. But the authors argue it delivers a better cost-quality trade-off than heavyweight proprietary reasoning models, which tend to be pricier. Also, they release code and the prompt templates, which helps with reproducibility.
Any caveats you spotted?
A few. First, they report results on validation subsets, 1,000 per dataset, so it's a good but limited slice. Second, while the framework supports graph evidence, most experiments rely on text. I'd love to see a controlled text versus text plus graph study. Third, the architecture is more complex than a single model call. Backtracking can add latency, and coordination among agents introduces more moving parts. Finally, long context tasks like MuSeq still favor models built for very long documents.
Right, so it's not a magic wand, but it's a thoughtful design move. What do you make of the comparison to O1 and O3?
The interesting part is that ReAgent, even with GPT-4o, matches or beats those strong reasoners on average across the three datasets, while the very long context case remains a point where those models shine. It suggests that reversibility and structured collaboration are powerful ideas, even without the most expensive backbone.
If you were to extend this work, where would you go next?
3 ideas. 1. Teach the system when to backtrack and how far, so it balances accuracy against latency automatically. 2. Plug in genuine knowledge graph retrieval at scale and quantify what that buys you over text alone. 3. Combine reversible reasoning with smarter memory or retrieval compression so it holds up better on long documents.
I'd add robustness tests. Throw in noisy or adversarial evidence and see whether the controller can downweight unreliable sources. That would tell us how sturdy the pipeline is in the wild.
Totally agree.
Before we wrap, remind listeners who's behind this.
Lead authors include Xinjie Zhao and Fan Gao, with collaborators at the University of Tokyo, the National University of Singapore, and partners including H. Cust. The work appeared at EMNLP 2025.
Perfect. Quick takeaway for our audience?
ReAgent shows that adding a principled reverse gear to multi-agent QA reduces error propagation and boosts stability. When evidence conflicts, don't just push forward, roll back, repair, and proceed.
Reversible reasoning as a first-class feature. That's today's idea. Thanks for listening to AI Podcast.
See you next time.